Okay, maybe we'll get going. Seeing it's nearly 5 minutes past the hour.
Okay, no worries. Hi, everyone. Thank you for joining us for the PIQET Webinar. We're looking at optimizing transport efficiencies and custom solutions. I'm sure you've already met Tim, but if not, Tim's the owner of Life Cycles and product developer of PIQET. My name's Gabriella Hooper. I'm head of marketing comms here. This is one of many webinars, and we have a few to come as well. So looking forward to hearing feedback afterwards.
Thanks, Gab. Okay, so we were going to talk about impact assessment, the second part of that, but we decided to push that off until we've launched PK5 because it sort of requires the prioritization by looking at all the impact categories and then looking which ones are contributing the most to the PEF eco score. Won't be available until PK5, so we thought we'd just leave that off. But we do get a lot of questions around transport, what to select in transport in PK. So we thought we'd just go through some of the thinking and detail behind the way transport is modelled both in LCA and then specifically how that's dealt with in PK. So maybe I'll just share my screen and hold on, I'll just do that because I'll need that later. So transport in general, and please ask questions, interrupt as we go. Don't feel this is not TV. This is looks a lot like TV, but it's it's a Zoom meeting. So when is transport important? As you may well have realised, a lot of the transportation, a lot of impacts of transportation often don't show up very large in many LCA studies. If the product itself has a reasonable LCA footprint, the influence of transport typically, rarely exceeds sort of 10% and is often down at a 3 or 4% or less. And so that's but if we look at it globally, at what the overall contribution is of transport, we have about 16% of total greenhouse gases come from transport. And however, a significant part of that is actually road passenger transport. So the road passenger transport is like 45% of road transport of transport in general. So once you subtract that, you end up with an overall footprint for road for freight transport, which we're mostly interested in PK, of around 6.8%, being predominantly dominated by the road freight component, small amount from air freight, and a not insignificant but still relatively small amount from shipping. And the shipping footprint is an interesting one because the overall impacts of shipping, overall dominance of shipping as a means of, in terms of total ton kilometres, if you look by different regions, shipping dominates more than 90% of the footprint, of the ton kilometre footprint of transport throughout most continents, with the slight exception of Middle East Africa, where it is just under 10%. So that really points to the fact that international sea freight is very, very efficient. That's sort of this is like the global warming impacts of transport. We do know that the impacts of particulate emissions, particularly from older freight vehicles, are quite significant. And so roughly 6.9 million people per year, my thing has gone nuts, 6.7 million people per year die prematurely because of particulate matter exposure. That's not all due to transport. Transport, though, is one of the major contributors to that impact. There's also some other data out now that shows even low levels of particulate emissions from sources, including transport, in countries where they are not heavily polluted, still does have a significant health consequence, although less than countries where you have a very high pollutant load. The other impact that was often associated with transport was smog, so summer smog or photochemical ozone creation potential. And we're happy to report that that is no longer the case. You can see with this, the contributors to smog have dropped dramatically from the point of view of road transport. And I think we can all give ourselves a pat on the back for, as an environment community, for achieving that. We still have a significant, haven't had very much reduction in the use of solvents and the impacts of solvents. And so those of you who are associated with printing, there is one of the major contributors to those solvent emissions, which contribute to both human health and smog-related impacts. And so that's other impacts associated with transport include the impacts from land occupation and then pollution from tyres and brake wear. There's an enormous amount of particles and materials actually just released to the environment through brakes and tyres, all of which are reduced slightly if you can go to electrification, but nevertheless it remains a significant source of pollution. While we've got a few of you online and we're talking about transport, we do have a particular issue on what to call different sorts of transport. So we might just go to Gab, if you want to show the.
Sorry about that. Can you see my screen, everyone?
Yep.
Cool. So just a little interactive part. If you could all just quickly scan the Menti QR code, it will just take a moment. And then we kind of get involved in the word cloud part. So firstly, if we just want to describe the following mode of transport, what would you all call this? I can go back if you haven't had a chance to scan the QR code, just let me know.
Yeah, sorry, could you give the code? Oh, sorry, 5845, it's in the top. No worries.
Yep. Okay, we have a B double. Truck. Okay, road train, road freight, B double truck. Any more? Okay, next one. What about this beautiful mode of transport? Okay, active road transport. Trailer. Okay, moving on to the next one. Another one.
Ooh.
What do you call that? not a lot of responses. Just one more. Hopefully we can agree on a few universal term for this. Cool. Van, transport van, van, road, light commercial. Van. Minivan. Nice. I might stop sharing my screen now.
Cool, thanks. So that's sort of helpful that they don't really have very well-defined names, which is rather annoying, given that we need to, in PK, we need to like call them. So in PK, we actually used, I can't remember our logic. We used to have very Australian terminology, and then we went to lorry and commercial truck. That differentiating between the sort of the larger trucks. Of course, we have the weight. We always like quote the weight range, which hopefully gives away what it is that the specifics of the truck type. Okay. So what I wanted to do was to sort of talk about how trucks are measured in LCA and how that sort of the nuances of freight efficiency work. So if you imagine a large truck like this, which we might call a semi-trailer or a lorry or a whatever else we call it, a lot of people call it a truck and a big truck. If it drives a kilometre with nothing in, no load, it consumes about 0.43 litres of diesel, and that combusting that diesel releases about 1.58 kilograms of CO2 equivalent, greenhouse gas emissions. We then allocate to that in the LCA software, it gets a proportion of the total manufacturing impacts of the lorry, about 0.23 kilos CO2, proportion of the lorry maintenance, 0.16, and a proportion of road manufacture and maintenance over the life of roads is allocated through to freight transport at 0.47 kilos of CO2 equivalent, which is really large relative to, if you think of any other product system, the impacts of those background infrastructure elements are typically 2 and 3%, where here they make up maybe 30% of the impact is the infrastructure that supports transport, which really represents the, I suppose, the fact that that infrastructure is very extensive. You know, there's a lot of road, a lot of it's not used much of the time, and so that's the first thing to note. The second thing is that, okay, it hasn't done anything yet. If it's just driven a kilometre, well then, okay, its achievement is not very much, but that's its impact. If we fill the truck with 30 tonnes of load and it travels that same kilometre, the fuel usage goes up. It doesn't go up by 30 times, or it doesn't even double. It goes from about 0.43 to 0.63 litres of diesel, and that increases the overall footprint of fuel emissions for that kilometre. Okay, so what we sort of take from that is that trucks use fuel whether they're carrying load or not, and they use a little bit more fuel as you add more load. But it's a relatively gentle slope of increasing fuel use per unit of load. And interestingly, at the moment, when you consider when you actually look into, you know, why a truck uses fuel, it uses it because of drag, aerodynamics, and it also uses it because of terrain, whereas pulling loads up hills and then essentially rolling down hills. As we electrify the fleet, that difference, that amount of energy actually goes down significantly, because they can have regenerative braking on the way down the hills, and then they can use that energy on the way back up the hills. The whole principle of regenerative braking and utilized in hybrids, as you know. So that will change the dynamics of overall freight, and it'll be much more about the aerodynamics rather than the hilly terrain. Okay, so we've got that set up. We then go and examine, okay, what's it like when the unit that we use for looking at freight in an LCA is actually referred to as a ton kilometre. Now, you don't see that in PK because we just ask you what kilometres have been travelled, but we then relate that to the mass of material that's travelled, and we create the total kilogram kilometres or ton kilometres of transport, and then we apply that to an inventory. And that's because your truck, the alternative would be you to tell us what sort of truck you're using and how far that truck goes. But that would assume the truck is only dealing with your product, and you'd need to know how many of your product are in that particular truck and how much load is on that truck and that sort of detail, which generally people don't know. So we use this thing called ton kilometres as a metric for movement of freight. And a ton kilometre is if you've got a truck with 1 ton in it and it travels 1 kilometre, that truck has travelled a ton kilometre. If we have the same truck with 30 tons of freight in it and it travels a kilometre, it's travelled 30 ton kilometres because of the fact that 30 tons of freight have moved 1 kilometre. And so you can imagine when we actually look at the footprint of those two activities, looking at what we looked at in the previous 2 slides, the footprint of this ton kilometre at the top is around 1.5 kilograms of CO2 equivalent per ton kilometre, while for the bottom one, its footprint is 2.1 kilograms of CO2 equivalent for the 30 ton kilometres, which translates into 0.07 kilograms CO2 equivalent per ton kilometre, as opposed to 1.5. So the footprint per ton kilometre of this truck at the top is 2 orders of magnitude higher than a fully laden truck. And so that has a real implication if you happen to be having a freight scenario that looks a little bit like this one at the top, and yet you point it to an inventory based on the one at the bottom. If we looked at that in more detail, we can look at how that footprint of a kilometre of transport looks like as you increase the load, which is basically just taking the data I've just shown you, but giving you more values of what it's like for at 0.1 tons right through to 30 tons of freight. So the footprint goes up, but it goes up relatively evenly. If we then divide that footprint by the load on the truck, shown below, so this is just a straight graph of what the load is on the truck, we get the answer is the footprint per ton kilometre at different freight loadings. And so it can be 15 kilograms of CO2 equivalent per ton kilometre at 100 kilos of freight on the truck, all the way up to, I think it's less than 0.1 kilograms of CO2 equivalent for the, or 0.07 as we saw. That's what the number is right at the top there. So it's actually, the number's quite stable from 20 to 30. The number isn't moving too far, but it's very unstable or very inaccurate if you're down in the less than 10 down towards say 2, then your freight efficiency is low, and the appropriate inventory really could be a vast underestimate of your freight if you use an average lorry. So the average roughly is somewhere around, for a 30-ton truck, is around 28 tons of freight. So which sort of suggests that most trucks are full most of the time. And that's partly because freight is really expensive. I wanted to look at some freight economics, but couldn't find really good data on it. But freight is an expensive activity, and therefore it you don't drive trucks around with 2 ton in them just for the sake of it, because it's costing you a lot of money. So you're always trying to put as much in as you can. So if we then go back and we look at what the freight efficiency is at different levels of freight. So for 30 tons, if you've got 10 tons on a 30-ton truck, you've got 33% freight efficiency. If you've got 100 tons, you've got 30 tons, you've got 100%. If you've got 1 ton, you've got 3% freight efficiency. So then to work out how difficult it is to get good freight efficiency, if you look at different products, so if you have beverage packaging, let's say you've got Coca-Cola or something, or milk or water, typically you get 100% freight efficiency pretty easily, and the truck's only half full. So you actually end up with the axles being fully laden with free headspace in the vehicle. Because really the limitations of the whole freight efficiency are that the truck only has a certain volume. You can't increase the height of the truck, and you can't increase the width anymore. You can sort of do things with the length, hence we have the B doubles and the road trains and things like that. But that sort of ultimately you can only put a certain amount of weight on a certain number of axles. So actually making it longer makes it a little bit cheaper because you only need one engine to pull the truck. But it doesn't actually change the freight efficiency because it's weights. The people who make roads limit how much weight you can put on an axle, because overladen axles essentially are what damage roads. So that's why you don't put 60 tons on a 30-ton truck. You might be able to build axles to be able to do it, but the roads can't have that much weight in one point. If you're carting toilet rolls, surprisingly, you can actually get about 45% freight efficiency. About 5% of that is pallets, because you've got pallets and boxes and some of those things which are a bit heavier than toilet paper. If that's assuming you can stack all the way, use the full volume or 95% of the volume of the truck, up to sort of 2.4 meters. Corn chips, you might be down around 10 to 15% freight efficiency if you're carting boxes of corn chips around. Note that the logistics companies you may think, if you don't know how your freight is being moved, and depending on what part of the supply chain and whether you're moving entire semi-trailer loads of it at a time or multiple semi-trailer loads, it may be that your freight gets mixed with other things. And so they may mix corn chips with beverage packaging because that gives them a well-balanced load and they can maximize their use of both space and axle load. So yeah, there's our orange juice, beverage packaging, our toilet rolls and corn chips. Okay, so that's the freight efficiency bit, and I'll show you in PK how we manage that shortly. Then we've got accounting for backhaul. So backhaul is what is happening with the truck after it's delivered your product. What does it do on the return journey? Or is it on a loop trip where it's dropping things to multiple places? So what fraction of the time is the truck empty or only partially laden? Now, PK has built-in assumptions for backhaul, which is different per country. So if we look across different regions, you can see in Australia, it's about 70%. In India, it's about 80%. In China, it's as low as 60%. Pretty low in Brazil. Very high in the US, and throughout Europe. So in places where I suppose commerce is equally distributed around the different regions, then you can always be doing something with the return trip, or it's easier to. In places where you've got a few dominant bits of activity. So in Australia, there's a very strong East Coast activity. So anything which moves to the West Coast has to come back empty. Maybe China, maybe it's a little bit dominated by sort of the more coastal regions. Not quite sure why China is so low. But yeah, interesting to see that it actually does vary across different countries. And that's built into the assumptions whenever you use a ton kilometre inventory in PK and you say what region you're in, it will take account of that backhaul effect. And the effect of that on the greenhouse gas emissions are quite significant. So from 50% utilisation, so this is where the freight basically goes from where you want it to where it's got to go to, and then the truck drives back directly empty. Down to the truck has a complete other task in the reverse direction, so 100% utilization. And so that ends up going from about 0.15 down to about 0.89 kilograms of CO2 equivalent. So that's about a 35–40% reduction in impacts between very high utilization and very low utilization. And so, yeah, if you look at, say, the China situation is sort of sitting here, while India is sitting sort of down here. So it actually makes us see quite an impact. So they're all the defaults that sit in PK. We have the defaults for, we have an average lorry, an average commercial truck, as we call it, the rigid truck. But you can, if it's important to your project, if your freight is more than 1 or 2% of the footprint, or maybe more than 5% of the footprint, or you are a perfectionist and have very specific data, you may want to go to create your own specific custom truck. I should mention that we provide some customization within the inventory by having, and so I might just jump into PK to look at this rather than on the static slide. So if we are looking at a transport situation and we're looking at a particular truck type, so you can choose the average lorry, or you can choose one of 4 bracketed 25, 50, 75 or 100% laden things. So that really is, you know, what freight efficiency do you expect to have on the vehicle. We also have urban and rural roads, which has a small effect on the overall fuel use by region. So that's the first thing. If you just want to say, okay, yeah, I think it's about 50%, you can use that. If you want to get more specific, you can say add a custom truck. Click, go to the custom truck area.
Sorry, Tim, we can't see the PK app.
Oh. So yeah, I was just mentioning that you have the different truck options with different efficiencies listed here. So lorries at 25, 50, 75 and 100% load. Same with commercial trucks. We don't bother doing it with vans and bikes and things like that. But if you want to get specific, you can click on the custom truck, click add custom truck, jumps you out. And like all custom items in PK, these sit outside of your project and are then utilizable anywhere. And let's say I want to add a custom truck for my toilet paper. So I can make it a toilet paper truck. And I can say it's going to be a lorry, articulated truck. Okay, it gives me a tear mass. If I choose a commercial truck, it probably gives me a smaller tear mass. Yeah, so it has an estimate of what it thinks the tear mass of the truck is. I can say the maximum load of an articulated truck in Victoria is 30 tons. And then I can go and calculate on the back of an envelope what the total weight will be going into the truck. And if it's 12.5 tons, I will then get a 41% efficient loaded truck. I can then do adjustments, and so if this is going from Melbourne to Sydney in Australia, we would have a probably 75% rural. And if I don't know anything about the empty returns, I'll set them at half. So pretty hard to know what that backhaul. So I think we were saying for Australia about 69%. So utilization. So that would be about there. If it is refrigerated freight, this is where you actually add the refrigeration. So if you add that it's going from Melbourne to Sydney, that's going to take 8 hours. So let's allow an extra 2, so 10 hours of refrigeration. And then I can go and specify that it's going to be refrigeration frozen, and that will add a certain amount of diesel engine use for running onboard refrigeration. And press save. So now I've got my toilet paper truck, and I go back to my project. I refresh these little arrows so that it updates the list, and now I've got my toilet paper truck here, and I can send that for I can send that for 800 kilometers. But just to let you know, our shipping lookup is returned. For anyone who was frustrated by the fact that the lookup for shipping was not working, it's now working. So I can now put in something from the Melbourne port and set that as the origin, and I can then send it to, say, Shanghai or Shenzhen, port in China. No, I'm China port. Let's send it to there, and then let's hope that it finds that. Yep, there we go. Went and found the thing, and it's using a new calculator from a new API, because the old one just disappeared on us. So, so that's how you can create your own custom truck. And again, you'd only do that when you really feel like that it's important to the particular study, or maybe your study is about freight efficiency. It's about getting more onto a pallet, getting the packaging efficiency. The other area where we deal with this is once you're in the supply chain and you've filled your product and you're about to move it from the filler to wholesale. So this is the first time when really a pallet load of goods are configured and being transported. So if you're adding transport to wholesaler, you can come in and you go to add, and you might say, okay, I could just use a commercial truck estimate. But PIQET actually does know a lot about what's on a pallet, because you've defined that in your packaging levels, and you've defined it in the packaging components, and you've also defined it by saying what is inside the product. So if I come and say I'm wanting to use a custom truck, but if as soon as you click custom truck, it comes up with this extra checkbox called calculation by pallet load. So I can choose my toilet paper truck, but I then click calculation by pallet load. It looks in and says this is how much. There's 567 kilograms or 0.56 ton per pallet. All I then need to add, because PIQET doesn't know this yet, how many pallets go on a truck. And let's say there are 36 pallets going on a truck. I've now got 67% efficiency, and I click, I have to put in the distance. And so it will now use that specific data from PIQET's knowledge about what your pallet configuration looks like to use that as a very specific efficiency on your truck. So you don't need to go and manually calculate using how many pallets go in the truck. And again, all of this presumes that the truck is just doing your job, your task, and not doing multiple tasks at the same time. Okay, so I think that's the main things we have. So accounting for efficiency and transport, the wholesale approach, the API, which I've just showed is now updated. Let us know if you misses any ports. I found one port in China where you couldn't find yesterday. But generally I think that's working. We do have the ability to model multiple transport logistics for an item. So if you've got, say you're buying widgets or resin, but you buy it from 3 suppliers because it's too risky just to buy from one supplier, you could have 3 supply pathways for your incoming goods. Or if you're going on the outgoing stage where you're distributing product, you can go and actually you develop a custom transport scenario, and you click the transport to and from multiple sites, and then allows you to specify how much of the product goes via each transport logistic. So, and what we're proposing to do in PIQET 5, probably won't be the one we first release, would be to have upload this from a spreadsheet, so you could actually have some, maybe 20 or 30 different transportation routes that you may want to import into the software in this way. But at the moment, you can do it manually just by specifying your main regions and how the material gets there. So as we go forward, we are looking to add some new transport modes. We currently have data on electric commercial trucks and electric vans. So we will add those. And given that a lot of the time, if you use an electric vehicle, its impacts will not be that great if it's based on the average grid, depending on where you are. But sometimes people will be, part of the purpose of buying an electric vehicle would be that you run it on renewable energy. So we will allow, have one based on average grid and one based on renewable mix for both electric commercial trucks and for electric vans. And the other one is there's some innovations coming into international shipping. And one of the main ones there is as companies using slow steaming to where they actually just slow the boat down, and that has a significant benefit in terms of reducing fuel usage. So that's a strategy being employed. So if you know that your shipping line is doing that, or that's part of its strategy, you can test the impacts of that on your overall process. Okay, that's about it. Any questions or comments or other issues you're having in PIQET or would like to know about?
Hey, Tim, I've got a quick clarification.
Yes.
In the project section of PIQET, if you're not adding a custom truck and you're selecting, say, 100%, I think it says 100% fully loaded, does that percentage refer to freight efficiency or the percentage of the truck's volume that's loaded with products?
The freight efficiency.
Okay,
yep.
Thanks.
Yep. So it might be, it's the percentage, it's the weight of the freight divided by the allowable weight of the truck. The truck still may only be half full, but it's still considered to be running at 100% efficiency because you literally are not allowed to add more weight to it.
Okay.
Yes, Elvira.
Yeah, can you hear me good?
Yes, we can.
Okay, perfect. Well, first of all, thank you very much for the super interesting presentation. I had a question regarding actually the last slides about these trucks, that are using renewable energies or average grid or whatever. Is there the same option in the conversion methods, for example, like to take into account that the company is like functioning completely with renewable energies or something like that?
Indirectly, you can do it, but not directly. But it will be an option in PK5. You'll be able to, for any conversion process, or you'll be able to switch on renewables. For conversion processes or manufacturing processes. The way to get around it at the moment, and it's a little bit awkward because we don't tell you how much electricity is being used. But if it's renewable electricity, it probably matters less because the impact of renewable is, of course, not zero. We don't. Well, some people will model it as zero and call it emission-free. We do model the infrastructure of producing renewable energy, but I'll just show you how you would get around it. So what you would have to do, if you've got a conversion process, and you would need to create a custom conversion, and you would go there, and we would say add the conversion, and it would be injection molding, for example, and then you can basically need to select the renewable electricity from. You've got to sort of pick which one you want, or you can add multiple if you want to. But so you said electricity from solar, and we know that you have to find out from us, or you may know yourself what the electricity is. If they're that engaged, they may know that it's roughly 1.2 kilowatts per kilogram of material. So that's the way to get around at the moment. If you send us an email, we can tell you what this number would be for a specific process. That will only work for conversions. And of course, some people who've been doing this recently have, of course, there are some processes where at the moment it's a mixture of electricity and thermal heat, either fuel oil or gas. If you were going to make that a renewable process, you would get rid of the gas and use electrical heat, but that's like changing the process a bit. So it gets a little bit tricky for us to work out what that would look like in a renewable process. So we may look if there are some emerging processes which typically used to have a high thermal component, and they now have like a infrared, renewable infrared heating with electric molding or something, then we may need to start to build some of those. But that would get you around that. I don't know whether we haven't yet proposed to go back into the material production to say that the resin you're buying is coming from a producer that is uses lots of renewable energy. That is trickier because it's not. There is, we go back one step further in the supply chain. We can isolate manufacturing or conversion as one process which has a few inputs, but we go one step back and we've got 3 or 4 steps in the supply chain. You've got the person producing granulate, you've got someone before that producing the precursor chemicals, and which one of them is using renewable energy, and the influence of renewable energy at that point is probably less important anyway. So for very electricity intensive products, we could produce, say, aluminium from renewable energy, which I know is a thing now that is appearing on the market. So that would be a way around it for things which are materials which are very electrically intensive and may become available on the market.
Okay. Okay. Thank you very much. It was really useful. Thank
Thanks,
you.
Avo. Any other questions?
Yeah, well, thank you for the presentation. It was very thought-provoking. I have a question regarding like refrigerated transport. Do you see much of a difference emissions-wise between that and normal transport?
Typically, it's as you saw, it is in hours, and so it becomes, but typically around sort of 10%, I think, additional load. We don't adjust it by region at the moment. Obviously, if you're doing it in Dubai versus London, you're going to get different values depending on the time of year, on how much energy is used for that refrigeration. Typically, it's not very much because you load the material cold and you're just keeping things cold. Like you don't cool the heat down, you don't put hot things in a truck and then try and cool it down. So mostly it's actually just maintaining a given temperature, which if it's well insulated, isn't as demanding. So I think that's the reason why it's not as big as you probably imagine. What we haven't got, and probably should add, is container shipping with reefer cooling. That which has that is available and is definitely a thing. So that's something we haven't. No one's ever asked for it, so we haven't gone to the trouble to put it in. But it's definitely there. We have some other things specifically that people have done for heavily refrigerated pharmaceutical transport, where you build essentially a pallet type configuration. You can build your own pallet out of batteries and steel and elements, and then you would reuse that pallet many times, but every time you reuse it, it would be recharged. So if it's something like an Envirotainer, you could construct your own refrigerated piece of kit, and so we have done that with some of our users in the past.
Okay, yeah, thanks for the presentation.
No problems. Okay, we might just leave it there. I assume your hand is still sort of sitting up there, and there's a new hand. Okay, well, have a good day, everyone. Thanks for dropping in. Gab, we don't know the topic for the next one, but do we know when it'll be?
I think Gab's gone off.
Cool, Gab's gone.
Offline.
Okay. Cool. I think it will be in about 2 months, so September, October. So it'll be in November, and we should be ready to be showing the new PK5. We plan to be starting to model and transition that then, so it should be pretty exciting. Okay, thanks everyone. Enjoy the rest of your day.
Thank you.
Thanks, Tim.
Much appreciated. Thank you.
Oh, bye.